Bismillahirrahmanirrahim. Good evening, everyone. Today I'll try to explain how we can solve the last homework correctly. I'm talking about the simple pendulum experiment. Many students asked me about how the question will be. Let me explain that. Will be like prove the acceleration of a free fall ball is equal to this number by using simple pendulum. I will not say work or do the simple pendulum experiment. No way. The question will be as a prove the acceleration, calculate the acceleration can be. To the table, according to the table below, I will give you the time number one and number two and the length of string. And the other will be on your responsibility. Here, I give this as 80, 70, 60, 50, 40, and the time to each one of this length, average, plus 1 plus 2 divided on 2, divided on 20 here. Why? Because I say to 20 oscillations, not to 10 oscillations like a previous question. And t square, because the relation between the length and x-axis and t square, not normal t at y-axis, because that is necessary to kind of plot the relation between all of them. These numbers are difficult to you. You can't plot numbers like this correctly. By that, let's use the rounding number to be simple numbers to can control on them correctly. Here, each at x-axis, each 20 centimeters of length, string length, equal to centimeter of x-axis, and at y-axis, each 1 second square equal 4 centimeter of y-axis. Here, the condition is right. 1, 2, 3, 4. 1, 2, 3, 4. That's right. Here, every 2 centimeters equal 2 centimeter of x-axis. That's mean 10, 20, 30. That's right. About the slope, here I have just two irregular points, and the other 3 points are correct, are regular. It's enough because the regular number is more than half about how much numbers I have in the column. By that, let's use these 3 equations. First one, t equal 2 pi divided this root L divided on A, multiple root to L divided on acceleration to disappear to make this L divided on acceleration be without root. We will say, let's take how I can say, let's say square, yes, to each side of this equation to be t square equal 4 pi square multiple L divided on acceleration. We know the relation between slope and acceleration is in this equation. Slope equal 4 pi square divided on acceleration. And from it, we can calculate the acceleration if we could calculate the slope from the plot. Slope delta t square divided on delta L of string to be 3.2.5. Here, be careful, because here I worked on centime, but here when I divided, I didn't say 50 minus 40. I said 0.5 minus 0.4 to make my last result unit be with meter divided on second square. Okay, it's up to you. You can prefer the longer way or shorter solution. That's up to you. The result is approximately near from the right solution, from the acceleration number, because that I can say it's acceptable. Let's talk about the conclusion, the relation between t square with secant square at y-axis and length of string at x-axis is linearly relation. Its kind is inverse. It's a simple conclusion. Now let's talk about the experiment about last week, the last one. I'm talking about the diode. We explained everything about diode. We talked about the semiconductors, what this is different from the conductors and isolators, and talked about the most important thing. It was the NP junction, and we said why it's named like that, and we explained the reason. Now, let's talk about how the question will be. According to the column below, determine the diode's kind, it's silicon or germanium. I explained in the class, we know the important information about silicon VF, the different potential at forward bias equal 0.7 and to germanium equal 0.3. From these two numbers, we can recognize this diode is silicon or germanium. Let's explain how the solution will be. VF, we have two columns, the VF about volt unit and current, forward current with milliampere, and I said why in the class. According to the electric circuit, like the previous video, I explained I'm talking about the math solution, the math part of diode solution, okay? Diode solution question. Let me decrease the screen more. Here, like the resistance, that's the Ohm's law experiment, V at x-axis, different potential current will be at y-axis. Here, each 0.1 volt equal 2 centim. That's been 0.1, 0.2, 0.3, it's right. And here, each at y-axis, each 20 milliampere equal 1 centim. That's been 10, 20, 30, 40, 50, 60, that's right. According to 180, after that, the plot will be like that, which explain the relation between different potential and current will be like curve that's been exponential relation, not linearly like the previous one at simple pendulum. Here I could to solve this question without any irregular point here, and I said let's solve this question without using a ruler, okay? We will do this line, this curve, by using our hand, okay? Conclusion, the relation between them is exponential relation. Its kind is increasing. After this point is very important, it's the VF. The first number at different potential, which lead the current through from N to P side across the diplegion region, okay? The first different potential led current to through was 0.6. This current was equal 10 milliampere from 0 to 10. And after that, an increase jumped to reach more than 180. Here, you have another example, another homework. You should to solve it to develop your skills to can plot another curves more easily. According to the column below, determine the diodes. You have these numbers, but here the numbers is different a little bit. 10, 130, 410. Let me say next week how you will plot this curve, okay? That's it. And don't forget to write your conclusion. Our lecture today is done. Thank you, bro. You're watching, you're listening. Have a good day. See you in next lecture.